we're going to have a test on October 6th after we finish chapter 3 and 4. Please go through PowerPoint presentation for chapter 3 and 4 and sample question and answers and get ready for the test. The title of chapter 4 is Climate Change. Climate change is coming from mainly carbon. Carbon is found in everywhere, oceans, atmosphere, deep in the earth as fossil fuels. Where does all the carbon atoms go? Carbon atoms seem to end up in atmosphere, causing global warming. We need to know how to quantify mass of carbon. Therefore, we have to know how to quantify certain elements. We're going to go through mole calculations. We're going to quantify carbon dioxide in terms of moles. Why does it matter where carbon atoms end up? It matters because carbon dioxide in the atmosphere causes problems. Carbon dioxide is a greenhouse gas. It has certain good effect on us, keeping us warm, but bad when carbon dioxide makes Earth warmer. So therefore, little of both. How do you recognize a greenhouse gas? It's based on properties of the molecules. We're going to look into that. Greenhouse gases work by reflecting thermal energy back to atmosphere, keep us warm. We need to learn from our past based on ice records in ice that allows us to monitor carbon dioxide levels in the atmosphere. We can also make prediction what's going to happen to us if we keep burning fossil fuel. We can look at the future world, how it would be if we don't do anything about global warming. We need to avoid global catastrophes. Who and how is the question. We're going to address some of these. The Earth is getting warmer, as shown in this diagram. Climate change is taking place. If you watch the video given in the link below, you can answer some of these questions about these controversial topics of climate change. Do you think greenhouse gases cause beneficial or harmful effect on Earth? Where does carbon dioxide in the air come from? They're mainly from human activities. Burning fossil fuel causes a lot of carbon dioxide too. Burning forests. What is climate change? Climate change is global warming, sea level rising, and turbulent weather. Is there evidence that climate change is occurring now? Explain. There's a carbon cycle that recirculates carbon through atmosphere, oceans, and Earth's surface. There are four main reservoirs for carbon. Atmosphere has carbon dioxide in 400 ppm level. Methane 1 parts per million. Methane is also a greenhouse gas. And carbon dioxide, carbon monoxide also present in trace quantities. Carbonate rocks on Earth and fossil fuels also contain carbon. Carbonate rock contain calcium carbonate, ionic compounds. Plants and animals where carbon atoms are combined with hydrogen and oxygen and nitrogen, organic compounds, are stored on plants and animals. Dissolved in the oceans, deep in the ocean, there are carbon dioxide. How much additional carbon can accumulate atmosphere in a year? We don't know the answer to those questions. It's getting warm and we need to do something about it. We're going to talk about ionic compounds to learn more about carbonate rocks, calcium carbonate. Ionic compounds are found in rocks as calcium carbonate, calcium ions and carbonate ions. Ions are a group of atoms or group of ions that have a charge by gaining or loss of electrons. Sodium ion loses one electron, makes sodium ions. Chloride ions gain electrons, make chloride ions, negative ions. Atoms that lose an electron become positively charged. They are called cations. Atoms that gain an electron become negatively charged. They are called anions. Both gain and loss produce an ionic compound with cation and anion. Ion charges are important for getting ion formula and ion name. Ion compounds are generally produced from metals and non-metals. Ions have common ion charges. In the periodic table, if you look into metals, they make cations. Cations are found, metals are found on the left side of the periodic table, and anions are found in the right side of, in blue squares. Metals make cations. Non-metals make anions. Certain cations have fixed charges. They have only one type of cations, shown in green. Transition metals in the middle, which is shown, for example, in red squares. Metals in red squares. make more than one charge cation. Therefore, we have to know what cationic charge are on them. It could be either of these. Group 1A, 2A, and group 17 halogen have fixed charges, cations and anions. Halogens have only -1. Alkali metal make only +1 cation. Therefore, we can get the ion charges from the periodic table. The preferred ionic charge for a particular element is based on their group number. Group 1 and group 2 form positive cations and +2 cations for group 2. Group 16 to 17 form anions. The last two to the right, halogens and oxygen group. They make -2 and -1 charges. Naming ionic compounds is slightly different than naming molecular compounds. Cations is listed first, then an ion. Suffix of the second element is changed to I. Oxygen becomes oxide, chlorine becomes chloride. Prefixes are not used as in molecular compounds or covalent compounds like carbon dioxide. Non-metal compounds, we use prefixes. Magnesium oxide is, MgO is, magnesium is the cation name, oxide is the anion name, it becomes magnesium oxide. Sodium is sodium, bromine is bromide, is called sodium bromide. We use Roman numerals for transition metals or element with multiple charges to show the charge on the metal using Roman numerals. FeO has +2 charge. Since oxide has, oxygen has -2, it becomes FeO, charge balance, neutral FeO. Fe is 2+, therefore iron 2 oxide. On Fe2O3, charge balance, iron has oxide, 3 oxide ions, has 6 negative. Therefore, 2 iron atoms should have 3 on each. Therefore, iron 3 positive charge on each iron atom. Therefore, iron 3 oxide. So from the formula, you can find the charge on the metal atom. Naming ionic compounds continued. An ionic compound formed between calcium and sulfur. Calcium makes +2. Sulfur is -2. Calcium ion is called calcium. Sulfide ion is called sulfide. Therefore, calcium sulfide. Formula should be charge balance. Calcium 2+, sulfur 2-, produce formula of calcium S. Fluorine and potassium produce potassium ions and fluoride ions. Their charge balance in the formula Kf. Therefore, name is potassium fluoride. Manganese is a transition metal. In the compound with 2 plus with oxide, charge balance in formula MnO, Mn2 plus, oxygen 2 minus, balances out charges. We have to tell what the manganese charge is by showing Roman numeral 2, therefore manganese 2 oxide. Manganese also forms positive 4 oxide. So therefore, formula should be MnO to keep the charge balance. There need to be 2 oxide ions to balance the charge on 4 plus on manganese. The name of the manganese compound is manganese 4 oxide. Chlorine and aluminum. Aluminum makes 3 plus, chlorine makes 1 negative. Formula is AlCl3 to balance the charges. There need to be 3 chlorides. Aluminum chloride is the name. You don't use prefixes like aluminum trichloride for ionic compounds. Cobalt make cobalt 2 plus with bromide. Formula is CO Br2. Name is cobalt 2 bromide. On the other charge ion, cobalt 3 plus, the formula becomes cobalt Br3. There need to be 3 Br bromides to charge balance the positive charge on the cobalt ion. Name is cobalt 3 bromide. So when you're naming transition metals, you have to use Roman numeral to indicate the charge on the ion. There are many polyatomic ions that contains more than one atom in the group, and ion is a group. They are fairly stable, stay together in reactions. Most are negatively charged. Common polyatomic ions, name and the formula. Acetate is C2H3O2 minus, 1 negative charge. Bicarbonate, HCO3 negative, is also called hydrogen carbonate. Carbonate ion is CO3 2 negative. Hydroxide is OH minus. Hypochlorite is ClO minus. Nitrate is NO3 1 negative. Nitrite is NO2 negative. Phosphate is PO4 3 negative. Sulfate is SO4 3 negative, 2 negative, sulfate. Sulfite is SO3 2 negative. I and the 8 has more oxygen. Like in nitrate ion, I means less oxygen, nitrite. Sulfite, sulfate. Sulfate has more oxygen. Phosphate has 3 negative, PO4 3 negative. Ammonium ion is the one cation that is polyatomic. Most of the polyatomic ions are anions. Naming ionic compounds with polyatomic ions. This is potassium, K. CO3 is carbonate. It becomes K2CO3 to charge balance. Potassium 2 plus now, carbonates at 2 negative, therefore charge balance. Formula is correct. So name is potassium carbonate. Ammonium is NHO. Bromide is the second element in the ionic compound with the I suffix. Bromide. Sodium bromide. Ammonium bromide, I'm sorry. So you can do problems. Potassium nitrate. I already said that. KNO3 is potassium nitrate. Ammonium sulfate. Ammonium is NH4. Charge balance. NH4 twice. Sulfate to charge balance with SO4 2 negative. Ammonium ion is 1 positive. Ammonium sulfate. Iron sulfate. Charge on the ion is 2 plus because sulfur is 2 negative. Therefore, iron 2 sulfate. This is sodium. HCO3 minus is carbonate or hydrogen carbonate. Sodium hydrogen carbonate. Magnesium phosphate. Mg3PO4 twice. To charge balance, you have to cross multiply. Both ions, magnesium has 3 plus, 2 plus, phosphate has 3 plus, you have to cross multiply to keep the charge balance. Magnesium phosphate. Naming ionic compounds with polyatomic ion. Write the chemical formula each of following compounds. Household bleach is sodium hypochlorite. Sodium Na, hypochlorite is ClO3, negative. Therefore, NaClO3, ClO, NaClO. Charge balance. Sodium is plus, hypochlorite is negative 1. Magnesium carbonate. Magnesium is 2 plus, carbonate is CO3 2 minus, found in limestone rocks along with calcium carbonate. Magnesium carbonate is MgCO3. Charge balance. Ammonium nitrate, NH4NO3 is used as a fertilizer. Ammonium nitrate, NH4NO3, charge balance. Ammonium is plus, nitrate is negative. Therefore, neutral charges on the formula. Calcium hydroxide. Hydroxide is OH. Calcium is 2 plus, therefore hydroxide is negative. There should be calcium OH twice. So you have to check the charge balance on the formula when you get the name from the formula or formula from the name to give the correct naming, correct formula. Global carbon dioxide emission are created by burning fossil fuel in transportation, heating, and major industrial processes. The carbon dioxide is produced from various activities. Every second, enough rainforest is cut down or burned to cover 2 football fields. That's a lot of trees. The major carbon dioxide emitter is power plants and heating stations to produce electricity. Next, industry. When cement is produced, calcium carbonate is heated up with sand and a lot of carbon dioxide is emitted in industries. Most industries emit a lot of carbon emission. The next, deforestation, cars a lot of carbon dioxide emissions. Burning wood cause a lot of emissions. Then we have agriculture, also produce a lot of carbon footprint or carbon dioxide. Transportation also produce a lot of carbon dioxide by burning diesel, gasoline, etc. Residential and commercial building, also heating and various activities produce carbon dioxide. The main cause of carbon emission is power generation. How do you quantify carbon? So we use the atomic mass. Atomic mass in the periodic table is the weighted average of naturally occurring isotopes of the element. Carbon has 3 isotopes. Isotopes are atoms of the same element with same number of protons but different amounts of neutrons. Their mass is different. Atomic number is same. They have the same chemical properties. Mass number is defined as number of protons plus neutrons. It's the exact number. For example, isotopes of carbon. There are 3 isotopes. Carbon 12, mass number 12. Carbon 13, mass number 13. Carbon 14, mass number 14. They have same atomic number. By having different number of neutrons, they become heavier. Carbon 12 has 6 plus 6 neutrons. Carbon 13 has 6 protons plus 7 neutrons. Carbon 14 has 6 plus 8 neutrons. The average atomic mass reported in the periodic table is based on abundance of different isotopes in natural sources. Carbon has 98.990% carbon 12, 1.10. There's hardly no carbon 14 in this radioactive. Therefore, the average mass of the carbon is calculated using these fractions. 12 times 0.98, 98.90 converted fraction is 0.98. 12 times 98.98 become 11.868. 13 times 0.11 produce 0.143. And this is almost 0. So when you add these up, the average atomic mass is 12.01. Therefore, atomic weight reported in the periodic table is 12.01 grams per mole. We're going to talk about mole in a minute. We use the concept of mole. A mole is defined as the carbon atoms which contains carbon atoms containing 12 grams of pure carbon 12 isotope. A mole. Mole has Avogadro number of particles, 6.022 to 10 to the 23, large number. It's a counting number to make small atomic particles measurable. So we kind of use as a chemist lesson in counting. The atomic number is reported in the periodic table is 6 for carbon. 12.0 is average atomic mass calculated based on naturally occurring isotopes. So every element has its own atomic number and mass number. To get a 1 mole of any atom that contains 6.022 to 10 to the 23 atoms, you have to get the atomic weight 12.01 grams of carbon. Therefore, if you ask the question, how do you get the 1 mole of certain elements? Go to the periodic table, get the mass, and get the grams of that mass. You have 1 mole of that atoms. 1 mole of atoms of element has mass in grams equal to the atomic mass of the element. Therefore, it's easy to get a 1 mole of any element or compound. Same number of objects will have different masses. 1 mole of carbon and 1 mole of helium will have same number of atoms but different masses. Helium is 4 grams, carbon is 12 grams. Avogadro number is the number of atoms in a mole of atoms. The counting number is the Avogadro number to make things easy for us to deal in chemical laboratories. Like dozen is used in egg counting. 20 is a score. 100 is a century. You count your scores in centuries, not one run at a time. It's make it easy. For atoms being so small, we need to use a bigger score. So Avogadro number is like a chemist dozen. So we measure different things. 12 eggs, 6 tennis balls, counting numbers. We use 1 mole. 1 mole of anything, like 1 mole of eggs has how many eggs? 6.02 to 10 to the 23. This is just a number to make our life easy. So we can use moles of materials to do chemical reactions. We cannot pick up atoms and do reactions. We are in a macroscopic world. We are big people. We need to scale up, atomic scale to mole, certain number of atoms, 6.02 to 10 to the 23 of substance or compound. Let's think about mole. We are taking 2 examples. 1 mole of marshmallows and 1 mole of pennies. Avogadro number is so large that only way to visualize it is through analogies. For example, Avogadro number of regular size marshmallows. If you take 1 mole of marshmallows, will contain 6.0 to 10 to the 23 marshmallows. That would cover surface of the United States to a depth of 650 miles. Or if you take pennies, if you like money more than marshmallows, you are given 6.0 to 10 to the 20 pennies, and you distribute evenly among the approximately 7.5 billion people, each man, woman, and child could distribute it among them, would be spending 1 million every hour, day and night. And half of these pennies would be still left by the time each person passes away. So there's a lot of Avogadro number of more dollars is a large number. Can this fantastic scheme be correct? You can check on your own, create your own analogies, reasoning. What is a molar mass? Molar mass is of a compound atom or compound is Avogadro number of atoms or compound molecules. How do you take a molar mass? Calculate molar mass. Molar mass is you take the atomic weight in the periodic table in grams, then you have a mole of material. Atomic weight taken in grams is called molar mass of that material, atom or molecule. Atomic mass is taken in grams for each element contains 1 mole. Molar mass of a compound is calculated by simply adding up the atomic masses for the different types of atoms. For compounds, you add them up. For example, sodium chloride will have 1 sodium atom, chloride atom, you add them up, you get 58.44. If you take 58.44 grams of sodium chloride, you have 1 mole of sodium chloride units. Lithium nitrate. Lithium is 6.941 grams per mole. Carbon is, nitrogen is 14.01. Oxygen is 15.99 times 3. So you add them all up, 68.95 grams is a 1 mole of lithium nitrate. So it's easy to calculate a 1 mole of molar mass of a substance. Molar mass of water is 18 close to 18 grams per mole. 16 plus 2 from each hydrogen makes molar mass 18 for water. So you use molar conversions using following relationship. If you have grams of material, you divide it by molar mass, you get the moles. For example, if you have 36 grams of carbon, how many moles? 36 divided 12, 3 moles. Then how many atoms are in the 3 moles? Multiplied by 3 times Avogadro's number. It's pretty simple. If you have 33 grams of carbon, how many atoms do you have? 36 grams divided by 12.01, this is factor label method, you get 3 moles of carbon. Then how many atoms of carbon? 3 moles of carbon multiplied by Avogadro number, moles cancel out, got 1.81 10 to the 24 grams atoms of carbon. So you normally easily could convert grams to moles, moles to atoms, or atoms to moles, and moles to grams. How do you get the grams or moles? Moles multiplied by molar mass. Grams divided by molar mass gets moles, moles multiplied by molar mass get back grams. Calculating mass of atoms. For these examples, you had to use these instructions. First, predict whether the value will be large or small. Calculate the value and see whether your predictions were correct. Think about whether your prediction are reasonable. So after calculation, you can do that. Average mass in grams of individual carbon atom. How do you calculate average mass in grams of an individual carbon atom? Carbon mole is 12 grams. 12 grams has a 1 mole of carbon atom. Therefore, 12 divided by Avogadro number is the mass of one carbon atom. So we use this conversion factor. 12 grams divided by 6.02 to 10 to the 23. You get 1.99 10 to the negative 23 grams of carbon. That's a very small number. We know, we can predict a carbon atom is so small. This is 10 to the negative 23. It's reasonable. The mass of 5 trillion carbon atoms. So you had 1.9 10 to the 23 grams, negative 23 grams is a mass of a carbon atom multiplied by 5 trillion. Trillion is 10 to the 12. So you multiply 1.99 10 to the negative 23, 5 times 10 to the 12, you get negative 11. It's still a small number, 5 trillion atoms. 10 to the 15, 6 times carbon atoms. Still it is 1.99 10 to the negative 23 multiplied by 6 times 10 to the 5. Still a small quantity. Therefore, atoms are small. So calculating mass, you will find you have very small number of grams in as atoms are very small. We're going to look into carbon dioxide emissions. With the knowledge of atom and molar mass, let us calculate how much carbon dioxide is produced from burning 3.3 gigatons of coal, assuming coal is mainly carbon. So carbon dioxide is, molar mass is 44. So therefore, 1 mole of carbon dioxide is converted to carbon dioxide. So ratio of carbon dioxide to carbon is 44 grams divided by molar mass of carbon dioxide divided by molar mass of carbon 12. Carbon is 12. So when you get the gigaton, same ratio, 44 gigatons of carbon dioxide divided by 12.01 gigatons of every gigatons of carbon dioxide will be converted to carbon. 12.01 gigaton of carbon is will be converted to 44 gigatons of carbon dioxide. So 3.3 will end up with 12 gigatons of carbon dioxide. That's a lot of carbon dioxide. How many molecules of carbon dioxide are in gigatons? 12 gigatons. We need to use our knowledge of Avogadro number and moles and conversion factor between grams to gigatons. So first, molar mass of carbon dioxide is 44. Convert 12 gigatons to grams. Conversion factor is 1 gigaton is 10 to the negative 15 grams. Therefore, 44, 12 gigatons carbon dioxide converted to grams is 1 gigaton of carbon dioxide, 1 times 10 to the 15 grams conversion factor. You get 1.2 10 to the 16 grams of carbon dioxide. How many molecules in there? So this divided by moles, Avogadro number, get the number of moles. How do you convert grams to moles? grams divided by moles. Grams divided by molar mass. I'm sorry. How do you convert grams to moles? Grams divided by molar mass. Get the moles. 2.7, 10 to the 14 moles of carbon dioxide. You get that number. So how do you calculate the molecules of carbon dioxide? Moles multiplied by Avogadro number. So it becomes 1.6 times 10 to the 38 molecules. So you see that how you calculate to calculation to convert grams to moles, moles to atoms or molecules. Or you can go backward and do the same calculation. Let's check on carbon from cars. Every car, normally engine emits about 5 pounds of carbon for 1 gallon of gasoline it burns. So average car runs 12,000 miles per year in the United States. Average car runs 28 miles per gallon. So you can calculate how many carbon pounds would be produced from average car. 12,000 divided by 25 multiplied by 5. 5 multiplied by 12,000 divided by 25, same setup. A car would produce per year 2,400 pounds of carbon. Weight of a compact car is 2,919. It means a car produces in its weight every year. It produces same amount of carbon in a year. So I'm going to talk about significant figures in Wednesday and go through rest of the slides in the chapter 4. All right, I'm going to stop the class now. Take care. Bye-bye.